All right, so this set of notes is going to cover the Industrial Revolution and sort of just the basics of the Industrial Revolution, and a lot of the key inventions that are going to fuel the industrial age. As with all of your notes, please make sure that you are taking time to jot down anything that you wanted to record, that you want to refer back to, etc. And as you're doing this, make sure that you're paying attention as the questions pop up and answering them to the best of your ability. So the Industrial Revolution begins in England. So we have the UK on our map here, but England is this southern little section of the United Kingdom. And then it's going to spread throughout Western Europe and the United States based on the trade relationships that they have with Europe and the United States. It begins in England because of key natural resources. Largely, England has a strong supply of coal, a strong supply of iron ore, and a deep, thick, that word is water. It looks terrible. Hold on. Let me try that again. That does not look like an A, does it? And streams and rivers and, of course, the coastlines in order to be able to develop mills that are water powered and using steam engines and that sort of thing. They have a steady supply of water in order to make this work. So that's the building blocks to why England was in a perfect position to have the Industrial Revolution take root in their kingdom first. So the Industrial Revolution is heavily involved in the cotton industry. So cotton is, of course, a plant that we use the fibers from to make clothing with. And the textile industry is the one that experiences the most change, the most rapid change in mechanization, and allows the mass production of cloth, which later turns to mass production of clothing and that sort of thing. The other major industry that is impacted first is the iron and steel industries. So part of the thing that you think about with the Industrial Revolution is the railroads and the skyscrapers that are built. And railroads are going to rely on steel beams as well as the skyscraper buildings, the structures of the skyscrapers. All of that happens based on the steel industry, which is revolutionized. This picture that you see at the bottom is a lady working on in a textile system. So that's where she would be creating. You can see that she's creating the threads here that are going to be used. There's several steps to the textile industry. One of the other things that happened in the Industrial Revolution is something called the British Enclosure Movement. And so part of the British system, part of the system, European system, that was a hangover from the feudal period is that towns and villages, etc., had these massive common areas, common lands. And actually, if you visit the city of Boston, there's a Boston Commons. It's a huge park. And it's all the concept that there are these common pasture areas that everyone, especially the peasants, could use for their grazing of their animals. It's not like peasants had a lot of animals, right? They did have some. Peasants had sheep or goats or a cow or two. And there's a law that's passed called the Enclosure Act that you can see from the picture allowed landowners to fence off that land. So they no longer were using those pastures for individuals. The peasants were no longer giving access to that. And what that meant then was that peasants who had relied on their sheep and their goats and their cows for their livelihood, if you were a shepherd, you had a flock of sheep and you were harvesting the wool to make cloth, or if you were a goat farmer and you were selling goat's milk and making goat's cheese or selling the goat meat, right? You no longer could feed those animals. And if you no longer had access to land in order for those animals to graze and live, you had to sell and move out. And what that meant then is that cottage industries, and this is where you have these factories are going to replace a cottage industry was an in-home industry where people were making their cloth at home. And the factory system is going to replace that system. It's more efficient, but also the peasants no longer had access to the land in which to use this. The other piece is that the countries in power needed a steady source of capital, and so what they were looking for is a way to control raw materials. And that is going to lead to the colonization of both Asia and Africa. We'll get to that in a little bit later when we talk about imperialism. But you can see from this map that unlike the early modern period where you had all these different African kingdoms, this map shows you that almost the entire continent of Africa is going to be controlled, is going to be a colony of a European country during the Industrial Revolution. So these are a few of the people that we need to cover for the Industrial Revolution. You have several key inventions that are going to pop up here. The first is James Hargreaves. He creates the spinning jenny. I'm actually going to talk about... I'm sorry. I was thinking that there was more than one of these, but it's just Hargreaves by himself. The spinning jenny is... You can see they have their little pictures, but it's got to do with how to spin thread. There's several different pieces to taking cotton and turning it into cloth that can be used for making clothes or something. And the spinning jenny is one of those pieces that was making it easier to spin the cotton into threads. And that way it increased the production in the textile mills. We're going to go down the list. So the next one is James Watt. James Watt creates the steam engine. Watt is a measure of energy and power, and it's named for James Watt. He created an engine. So the way the steam engine works is you have a boiler, and it heats up the water, and the water boils then and turns to steam, and the force of the steam turns the turbines in the engine. And so the steam engine is applied to trains, right? It applies to vehicles. There are some vehicles, early vehicles that are steam powered. It also, on a larger scale, can run factories and electricity. Cotton gin, Eli Whitney's cotton gin is one of the things that most people by the time they get to high school have heard of Eli Whitney's cotton gin. It was a machine for separating the seeds from the cotton itself, which was a task that took a lot of work to do by hand. A lot of slave women in the South spent their days, once the harvest came in, separating it with these paddle brushes, essentially. And it was hard work, it was labor intensive, and it was really hard on your hands. And the cotton gin takes care of that. The interesting thing about the cotton gin then and that impact is that it was doing it much quicker than a person could do it, because it's a machine, and the machine was functioning faster than doing things by hand. And so as a result, they needed a more steady supply of cotton because they were processing the cotton faster. So Whitney's cotton gin actually leads to an increased demand for slavery in the American South and some places abroad, because there were more slaves needed to harvest. So that we were going to make, in the United States, they were making larger plantations to plant more cotton, to take care of the cotton during the summer, to harvest the cotton, because the cotton gin was ramping up the production capacity. And when you team it with the spinning jenny and some of the other textile mill inventions, people were processing everything so much quicker that they needed more cotton. There was a higher demand for cotton sources. Henry Bessemer, he doesn't invent steel. Steel is an alloy, and they'd been using steel for a while previous to Bessemer's invention. But what he does is he comes up with a faster way of making a stronger steel. So the Bessemer process is a way of heating up the metals, liquefying the metals, and then cooling them in molds to make whatever you're making the steel out of. But it's a much faster and also much stronger product. And so the Bessemer process was then used to ramp up the production of steel, which also is going to, in part, ramp up the mining industry because they needed the metals to combine into the alloys to make the steel. Edward Jenner creates the first vaccines. He creates the smallpox vaccine. And so they do that. They run several trials, including trials on kids. But what they did is he noticed a trend that women who were milkmaids, like their job was to milk cows by hand, um, were less susceptible, almost never contracted smallpox. And he theorized that that was a connection to the fact that they worked closely with the pox that impacted cows, which is a similar disease. And so that's what he did to create the smallpox vaccine, is he started inoculating people with this cowpox version, this strain, and that was helping the body defend against smallpox. Of course, with the adaptation of the smallpox vaccine, the death rates from smallpox are going to decrease, which population then is going to increase. And then with the science behind the vaccine, they're able to create more and more vaccines to eradicate more and more deadly diseases. The other thing, another public health, is the pasteurization process. You probably could go look in your refrigerator right now and find something that is pasteurized, whether that's cheese or milk or whatever. Pasteurization is simply the process where we boil liquids to a very, very high temperature, and then we cool it very, very rapidly. And that hot boil, and then quick cooling process eliminates the bacteria. If you cool it slowly, the bacteria in the environment will attach and grow and continue to live, and it'll spoil your food or your beverage or whatever faster. So he creates the pasteurization process with the understanding of bacteria, and then that has led to increases in public health. So that's where we're going to stop for now. If you have any questions, as always, let me know.